Okay, we've been taking a look at normal distributions, and last time we had like our whole bell curve basically looks like this, and we memorized or should have certain z-scores that gave us certain percentages. Like in my little drawing right here, this would be 68% of the data, and so on and so forth if that was one standard deviation. But data doesn't like necessarily fit into each of those deviations exactly. So our z-score can tell us where in the distribution our data is. And so I set up an example here. Now I'm going to be doing a lot of calculator work, so this video is going to focus on how to do all of this on the Casio. So anyways, here's our example. We have Joey average score in a game is normally distributed with a mean of 18 points. So this is an important piece of information, but for most of this section, we'll just assume our data is normally distributed with a mean of 18 points and a standard deviation of 3 points. And we want to find the probability that he scores more than 25 points. So on my little diagram right here, in the middle would be 24. And with one standard deviation to the right is 27. Well, wait, no, my mean was 18, my bad. So 18 was in the middle. So 18's in the middle. And then to the right of that would be 21. And then to the right of that would be 24. And then to the right of that would be 27. So this first one we really could do using that memorization, but we're going to use a different method. So the 24 lies right here. So probability more than 24 would be 24 and then to the right sum. Okay, so here's how we're going to use our calculator. First of all, we're going to identify our mean. This is our mu. And right here is our standard deviation. So we go to our calculator and we're going to press menu. We're going to go to statistics, of course, because that's what we're doing, statistics. And we don't need the list, though we could do a list. We want this thing right here, distribution, D-I-S-T. And when we click on that, we get a bunch of different distributions right here. We want norm. So we're going to press that because we're in a normal distribution. Now we have a norm PD, NCD, and inverse norm. Right here is what we want, norm CD. So norm CD, our data is going to be variable, and right here we could switch to list data, but we're going to do variable data. Now, lower and upper bounds. Let's kind of take a look at that in a second. Our standard deviation, this is going to be our 3 in our example, and our mean is 18. And now let's talk about this lower and upper. What that's talking about is on this curve. And our lower bound in this example is 24 because that's the lowest that we want if we want him to score more than 24 points. And then, well, what's our upper bound? Now, our normal goes on forever. So I'm going to say 10 to the 10th. That's a way to cheat it and say basically infinity, you know, technically it's possible that Joey could score, you know, infinity points. It's just not probable. So our lower end is 24, and our upper end will be 10 to the 10th. That's the way we're going to tell our calculator basically infinity. And everything's already plugged in. We'll just press enter until we get it. Now we get a very small percentage right here. Now this is 0.0227. Now that's the decimal version. If I wanted the percent version, which sometimes they ask for, that's 2.27%. Now let's take a look. We want the probability of less than 13 points. So if I look at my little drawing right here and I finish drawing this, this would be 15 to the left and then 12. So this is where we actually want to be able to use our calculator because our 13 lies somewhere right here and it's in between exact deviations. So we want less than that. We want this part of our distribution, the left-hand side, which means our lower bound is going to be negative infinity and our upper bound is going to be that 13. So we keep this data the same, but our lower is now going to be negative 10 to the 10th, and you do need that negative right there to indicate that we want negative infinity, and our upper bound is going to be the 13 because we want up to 13 points. Now the probability of that happening is 0.04779. So 0.0478, which is 4.78% chance that he would score less than 13 points. Now in this one, we want the probability between 16 and 20. So if we take a look right here, that makes it easy to put in our lower and upper bound. We want between 16 and 20. Okay, and 49.5% chance. So 49.5% chance that he scores between 16 and 20 points. Okay, so let's take a look at another example. A computer company found that on average, it will sell 400 CPUs. So this is our mean with a standard deviation of 15. Okay, what is the probability that this company will sell between 390 and 420? So we go back to our calculator. We make sure, again, we are in statistics menu. And our standard deviation is 15. Our mean is 400. And our bound, so our lower bound we want to be 390. And our upper bound we want to have as 420. Okay, and we get 0.656. Now that's the decimal version. That's 65.6% chance that happens. Okay, the probability of no more than 350 sales. So if I look at my distribution, in the middle is 400 because that's my average. And if I wanted one standard deviation over, that would be 415. And if I wanted one standard deviation back, that would be 385. And then so on and so forth. So I want 350. 350 is somewhere over here. So I want this piece no more than 350. So I want from negative infinity, so negative 10 to the 10th, to 350. Okay, so I don't need to change any of this, but my lower bound is now negative 10 to the 10th. And again, that's just saying infinity, negative infinity. And our upper bound, we don't want to go beyond 350 sales for some reason. We want to know the chance that he's not doing a good job. Now we do get this very small number here. I don't know if you can see. Your calculator might put out something like this, 4.29 E, and then mine said -4. And you might be wondering, well, what is that? Well, that means move my decimal point left 4 spots. So our percentage is actually pretty small. 1, 2, 3. There we go. So I moved it 4 times. See, 1, 2, 3, 4. So what's my percent? Well, 0.0, if I change it to a percent, there's a very small percentage chance that he makes no more than 350 sales. This probability, no less than 440 sales. So in our distribution, 440 is somewhere over here. We want no less than that. So we want this portion of our probability. So our upper bound is now 10 to the 10th. And our lower bound, we don't want to sell any less than 440. Oops, I put that in the same spot. So 10 to the 10th. And then 440 is our lower. And now we still get a small percentage here, 3.83. And this has a -3, so it was basically saying E -3. That means move this 3 spots, so 0.00383. And then if I wanted that as a percent, 0.383%. Okay. The cost of gas is normally distributed with a mean of 3.5 and a standard deviation of 0.12. Suppose there are 50 gas stations in the area. How many gas stations price gas at over $3.60? So first, we're going to need to find the probability that we find a gas station that charges this amount. Okay, so the mean is right here. There's our mean, and here's our standard deviation. So I'm just going to switch all this information up. All this stuff is a lot of calculator work, really. So our standard deviation was, what was it? 0.12. And our average was 350. We will remember this as dollars and cents. Now I want gas over 360. So my upper bound, they could charge $1 million if they wanted. Not probable, but they could. But our lower boundary is going to be that 360. Okay, so I have 20.23 or 0.2023, and that's 20.23%. Now that's the probability that we find a gas station that charges that much, but the question asks how many gas stations charge that much. So I'm going to do 0.2023. I'm actually going to use the decimal, and I'm just going to multiply by 50, because there's 50 gas stations, and there's about a 20% chance that we have a gas station that does this. So I'm going to go back to my menu, and I'm going to go back into my normal, my run, 0.2023 times 50. And I get 10. So 10 gas stations are charging a lot. All right, how many gas stations don't charge more than 330? So if I take a look at my curve, my average is 350. I'm wondering, well, what's the chance I can find a gas station that's down here at $3.30? So all these gas stations, that's where I want to get my gas. So how many do I have? Well, let's find out. So we go back to our statistics menu, and again, we find distribution. We're going to do normal, norm CD, and we're going to go to put in this information. It's already in. So our lower is negative 10 to the 10th. So what would that mean? That they pay you to take gas? I don't know. It's not probable, so we don't need to worry about that. Upper value. We don't want more than $3.30. All right. So we got 0.04779. Okay, so that's a 4.779% chance that if I pull into a gas station without looking at the prices, that I pull into one that's charging $3.30 or less. So, but the question is, how many of them are there? So I take this and I'm going to multiply it by my 50 gas stations. So I'll go back and 0.04779 times 50. And we find there's 2 gas stations, basically. There's 2 gas stations that are charging $3.30. Got one more example. So in Chemung County, the average ticket, so police officers pulling people over, is $200 with a standard deviation of $25. The court is reviewing 30 tickets today. How many tickets are between $180 and $210? So I'm going to put in my statistics. Again, distribution's what we want, and norm CD. We'll do inverse norm later, and we aren't going to worry about norm PD. So our lower is 180. That's the cheapest ticket that we're talking about. And the highest ticket, what was it? 210. So 210 is our upper. And our mean is actually this is standard deviation. That's $25. And our mean was $200. So I put that all in. A 44% chance that I get a ticket in this pile of 30 tickets. 44% chance that it's between these two numbers. So, well, what is that anyway? So 0.4435. That's a 44% chance times the 30 tickets that I have. And I get 13. So 13 tickets are in that range. Okay, how many tickets are less than $170? So if I take a look at my distribution, my mean was 200, and I want 170 is somewhere over here. I want these tickets. So, go back. I don't need to put the distribution information in again, but I do need to alter this. So less than 170. So negative 10 to the 10th will be my lower bound, and the upper bound is 170. And let's see here, 11.5% chance. Now the 11.5% chance, that's not our actual answer. I'm going to take this and multiply it by 30, and that will give me the actual number of tickets that are less than $170. And we get 3.5, pretty close, but basically 3 tickets fall into that category.